problem. In particular, our auto-build system we decided to build and to use. Sambas is much more than a file server these days. We're an Active Directory domain controller. Please come down to the front. That's what I particularly work on. We're a domain controller that's more NT4-like. Domain membership, print server. I haven't even mentioned, the minor, clustering. Plenty of other things that keep us very, very busy. A client library, print server. There are so many things that we do. And Samba is an old project. And so we've sort of started moving towards this continuous integration from a base that's very established. We have a global contributor base, which means it's very hard to get everyone into the same room to sit down and decide, okay, we really want to do this, or that testing is really important to us. It's long discussions on mailing lists and other painful things. It's conservative. We really don't like changing the way that we do things. Changing a version control system is a major thing to be done when somebody's on an international flight and can't yell. And historically, we've also been very portable because Unix was much more diverse 20 years ago. We've got a continuous development model where we run head, trunk, master, depending on which version control system we've used, and a release branch. So it gives you a bit of an idea of the background of where we came from, stepping into a continuous integration system. Now, while everyone can come down the front, you're really not allowed to sit on the stairs. The fire regs really don't permit that, so please come down the front and have a seat. Yeah.
If people want to move in, that would be really helpful as well.
Now, one thing, I've got a nice long slide and not a terribly large amount of slides. I would really like this to be an interactive discussion, so I strongly encourage questions from the floor. So please have your hand up or yell out. Samba really needs testing. We are very large, we are very portable and very complex. OpenStack, I guess, is of similar complexity, but it's this is in one project. It's not multiple branches and things, but the parts that have to work together are very large and usually involve multiple hosts on a network. And also our testing is a key part of how we built Samba. We built Samba by writing tools that we could potentially use to test Samba because we needed to go and see what does a Windows server do if I ask it this, and so we would then try and do the same in Samba, and so that's how you check that you get it right. So we'd write our SME torture tool, and we'd write that to work against Windows, and we'd run it against Samba to check that we matched. So the idea of testing and keeping our code working is very much part of the long-standing Samba tradition. And we've always wanted to do it, but haven't always got around to it. For many years, we had trouble keeping the code even compiling. Someone would go and ship in some code that they were sure was really, really good and was important for the strategic direction of Samba. It just didn't actually work. Compile even. This caused much, much frustration to some of the members of the team. But we've slowly been automating our way out of this problem. And look, I've put in code that hasn't compiled. It's very easy. Quick fix that, git commit that, go off to lunch overnight, whatever, and you've busted the tree. I'm just as guilty as everyone else. And you feel very much in shame the next morning when someone says, I had to fix that up for you. So we've increasingly gone for automation. Same reasons you've been hearing from the OpenStack people, except we've been trying to slowly do it rather than a new project staying up in the last couple of years. This is a slow process, particularly over the last 10 years. Fully automated enforcement, the gating that we've been, the last presentation was talking about. And we certainly found that Moore's Law helped a lot. The testing that we're doing that would have been completely impossible to do, this amount of testing 10 years ago, we now sort of do every commit that goes in. No commit goes into Samba now without testing. But what we do is hard. We are a network server. We are doing real TCP/IP to real clients and real servers and we have a file server that needs to impersonate users. We have a particular challenge that we have set ourselves. You've got to remember that a lot of our test systems started before virtualization was just an everyday availability. So the requirements and the bar that we set ourselves was that our testing had to be as non-root. We didn't want to be running developers to have to do all their tests with just root. We don't even want to touch the real network because the test hosts that we run our testing on are often donated machines where access to loopback is the most we want to do, and even then we could be an untrusted machine. I once had machines running on HP's, they had a developer farm of their various operating systems, and so did SourceForge for a while. And of course these were massively multi-user systems. So we didn't even want to trust that someone wasn't attacking us over loopback. The tests had to be non-destructive. Again, before the days of virtual machines, we could just blow the lot away. We had to do this on the developer's workstation, have it just work. It had to be unattended, you had to just be able to make tests, and it had to be secure, like these multi-user environments that were running build farm nodes. So we've really set ourselves a ridiculous bar in terms of base to work with, but we have achieved it, and it is the foundation of Sambas testing today. Any questions so far? Anyone think that what we've done is totally insane? Good, yes. Good.
Why particularly do the tests have to be secure? I mean, if someone attacks the test suite, which causes the test to fail?
Well, no, if they could attack this test suite, they could then attack the account the test suite's running on. And the accounts weren't at that stage and still aren't disposable. For example, we would get one build account on a potentially shared node, and so we wouldn't want to have that. And that account then had privileges to upload its test results back, so we wouldn't want someone to be able to attack that account. Yeah. So yeah, that's why they had to be so secure against other users. So we started faking it, and we have been faking it ever since. We have been faking sockets. So we actually translate every time that you make a socket-related network call, and it even goes as far as read and write because things we do. The idea was, surely if you just get the first few calls to a socket, the socket and bind calls, and you flip the parameters, and they don't say TCP, they say Unix domain socket, and you pass that down to the kernel, then everything else is just a socket, right? And then so then it all started to work. Of course then, but I want get peer ID to work. Okay, so you fake that. There are different ways to read and write to a socket. There are, and we've basically got everything you can do to a socket, we've got a socket wrapper replacement for. And it basically says, is this a network? Because one of the things is that we found that once we started having these fake sockets, we would use them a lot. But then we're rather addicted to Wireshark. So how do you sniff a Unix domain socket? Well, you have your socket wrapper library write PCAP files to disk. And yes, I do use this when debugging things, and it's a real formatted PCAP file. I think we don't do the checksums and things, you turn that validation off, but it's a real PCAP file, and yes, I do really bring it up in Wireshark to look at, okay, which packet failed here, why? NSS. So this is name server switch, not the security layer. So we have an NSS wrapper. So when you do get PWN, get PWNAM, those things return values that we say because we can't add new accounts to our test systems. System UID and GID. So we wrap the get UID, get GID. It does make problems that the actual stata file you've created is owned by someone else, but you can at least get most of those things. But to work that, I also have, extended attributes. You can't write to the system extended attribute. So we put that in a TDB. What have I got? Own a group and mode. Well, I put those into an extended attribute, which then goes into a TDB. POSIX I've started doing, because we were not testing. Without being root, we couldn't test our POSIX code. And that's a big part of being a Sambas server. So we fake that as well. Sometimes we find we're testing a very unreal world, but it lets us, without having whole machines to throw away at the problem, and very lightweight to start, actually get most of our code under test. I haven't put a slide up about it, but we actually get to about half the lines of code in Sambas, which for a automated testing system is considered pretty good. Going above that, you have to start chasing the failure cases on memory allocations and things, and they're very hard to. There are ways of doing it, and if Rusty's around, he's got a great way of doing that. In fact, he's using it a bit somewhere in Samba, but we don't use it generally. So that's the real big challenge that we've set ourselves up. So the journey started with a thing called the Samba build farm. And that's what, in many ways, set the requirements that send us down this silly road. Maybe we say now we would just do, okay, you're running this virtualization platform and you'll run this thing on it. But the other thing is that we wanted every developer, no matter what variant of Linux, no matter how they were configured, you had to be able to run make tests locally, and it had to work. Because the way this started, this wasn't we had this big central infrastructure with continuous integration, there'll be this environment for tests. It really was, it started that the developers were expected to run tests locally, and we had the build farm. Samba build farm is a series of donated hosts, like I described, and they get sent out a copy of the Samba tree, they pull it in under rsync, and if it changes, they go and they build it. And if it builds, they run make test. If they test, and as those pass, it then uploads the results. It only started with just compile testing. This was a bit over a decade ago. I started my first job on the Samba team. I was hanging around the Samba project. I had some patches and things. But Tridge and Jeremy didn't quite trust me to be doing C code. See, no one had taught me C. I just sort of picked up the compiler and I kept banging at it till the compiler shut up and it stopped segfaulting. So apparently they weren't quite ready to let me go on writing C code. So they said, but they wanted me on the team. Apparently I was, they spotted something in me. So they said, well, why don't you work on the Samba build farm? So from the horrors of C, I was off writing POSIX shell code. That was torture, particularly as it wasn't just bash, it was POSIX shell, because we couldn't assume we even had bash on these hosts. And so one of the things I added to the new Samba build farm, which mostly at that stage ran on about 5 or 6 hosts in Tridge's loft, was I added the first testing to that. And that morphed, I can't figure out when, into make test. So you could type make test and get some tests to run. And this was the first point where we started thinking about this secure. We were doing sockets. And we actually came up with a thing called, before we did socket wrap, we had socket pair. And there's a particular combination of system calls you can do where you create a socket and you can bind, I'm not trying to remember how it worked. You did a bind and you did a connect. And if you knew to yourself, and because it's non-blocking, it connects, and you knew that if both ends had succeeded, then no one else could have been in the way because you got the port with one line of code, you connected it with the other, then you checked whether it had been connected, and then you forked off and you gave one pipe to the child, one to the parent. So we gave one to SMBD, one to SMB client. As this was our first instance of making sure that someone couldn't attack our test system. Anyway, so we had this was how primitive the systems were to start with. And we literally would just run one SMBD, one SMB client and get things going. Then we started make test and then started getting into very complex build environments. We now get to the stage where we start up a Samba server, a fake network, and we start up multiple clients, aim them at it, do all sorts of things. We start up 6, 8, 20 Samba servers. The journey continued through to subunit, which is a testing protocol, which describes what the test name, whether it succeeded, whether it failed, and then a blob about why it failed. And this subunit has become the core of our testing thing. The Python test libraries that we use are built around these subunit protocol. And anything that isn't, we basically make talk subunit. For example, if you just do a black box test, well, we just wrap it in some shell that makes it spit out the right stuff. So we started doing this, and we had a make test system that was built around, and our build farm also outputs fancy JavaScript all based on this subunit stream. Then we went to auto build. So the idea of
your build farm emits JavaScript stuff based on your subunit stream.
Yeah, it just does some trivial parsing of it, so you can go plus and see a failed, succeeded or failed.
So do you have that as a self-contained thing? Because we wrote a little crappy thing to do that.
Oh, okay.
But it's crappy, it's terrible, and we want to be better.
Yeah. Grab it from their build farm Git repository. I don't know whether it's any better than yours, but but
Clearly, we shouldn't have two.
yes. And yeah, so it reads a subunit stream and it says name of the test and then of our release branches as well. As I said, automation has never been enough. Make sure to pass on e-developer workstation, but folks still broke the build. I broke the build. For a decade, we've been able to run make test, but we still had releases go out when make test failed. Who, as a programmer, has been the optimistic programmer? And everyone else is lying. I mean, yeah, it's...
Change anything!
it's exactly...
I'm supposed to run make test before I push?
Yeah.
Oh.
Well, the problem was, though, that our make test got a little long. I mean, it now takes 90 minutes to run make test. Developers do not have 90 minutes of patience. And so we would regularly have, oh, well, look, it's got 3/4 of the way through, it can't be too bad. So, oh, look, that was failing before I started, I'm sure of it. So it really was and yeah, we all did it. We all, and we started having the build farm sending us out nag emails. If it detected that your commit broke the build, or because of course the build farm was running asynchronously, it'd send out to 5, 6, the whole team, saying these commits broke the build. It was particularly amusing when a build farm host came back online, came back up dead after say a couple of months, and it would mail the whole team say, all of you responsible for last 2 months' work broke the build. Anyway, it's so we had a lot of the infrastructure, but it still wasn't getting us close. It was getting us close, and we'd work hard. We'd work really hard to get it all clean. We'd get every test passing, and then it would atrophy, and 1 or 2 tests would fail, and it goes back to a number of them failing. And then, of course, as soon as things are failing, people expect failure. They say, oh, well, look, 2 or 3 tests are failing. There's always 2 or 3 failures. It's not my problem. Someone else broke that a while back, and I have no idea. It's not my area. Look, I'm just going to, push it back under the carpet. So the build farm just wasn't enough. It is great. The build farm is running on multiple platforms. It's finding out about portability issues. But, people weren't looking at the web pages for the output. Our web page thing has got very slow of late. Our latest rewrite in Python wasn't a success. And so I described the guilty developer emails. But we also had flaky tests and flaky build farm hosts. And you get, oh yes, you always get an email from that host. Amate will remember this particularly. Oh yeah, that host always complains, and there'd be a flaky test. And so when it flaked down to being 1 less test, nothing happens. Then bump back up when that test broke again, and it's just pure random. And then you get, oh yes, you broke 1 test on this host, and of course you didn't. It was just a flaky test. So everyone's just busily ignoring it. I think we should probably shut the emails off by now. And there's just no incentive. If you change this in, why would you bother fixing it up? Well, I mean, you're meant to, I know, and it's your responsible thing, but, if you don't think it was your problem and things, it was in a different area, there's no real incentive to dig into it. And, some very diligent developers, usually the ones who aren't developing so much, they go in and dig in to check, yes, it really couldn't possibly have been mine. And the rest of us just sort of start to ignore them. This is stolen from Amate's slides from last year. Just a description of just how the build farm comes together. It's a cron job based system and distributed out to the different nodes. So out of all this, we started autobuild. It actually started trying to head off a debate in the team about code review. Code review is a great thing, but at the stage we had a real problem where it wasn't necessarily just about code review, it was some team politics in it as well. And we wanted to try and figure out some cheaper way, basically throwing money at the problem rather than developer time and attention, so that we could try and improve our quality through automated processes, which is something I really believe in, is that we've got to do the automated stuff first. And we've since made a decision to go to a full code review, currently on a voluntary basis in Sambas, and testing that out. But so it started out with a debate about code review, but if I'm going to review code and it's just going to land in master, should I be compiling and testing it? Even if the test takes an hour? Or do I put that off to the side, run the tests, go and say, oh yes, that one commit thing's fine? Or do you just end up blessing changes that you haven't compiled or tested because, look, someone along the line will test it? I mean, then what's your review worth? So we went and we purchased a 24-core machine and hosted it at Cernet, one of the big companies doing a lot of sample work. And we wrote autobuild. It's not actually a very long script, but the concept is, I think, very useful. We do not invent it here very well. I know there's great presentations about these, big integrated systems for doing all this. Like most things, it's one of the things of, oh, surely we can do it simpler. And I actually do think that for the size of projects Amber is, we've got a lot of complexity in existing components in our test systems, but there really are gate into one make test command. And so we built a continuous integration system that just sits in a single Python script and a few cron jobs. The Python script can run on any host, so we're back to any developer can run this anywhere. You don't need the infrastructure to run your tests. And what it simply does is that it rebases the Git tree, if it's told to, otherwise it just runs in your current tree, particularly if you're running it locally. It builds Samba. It builds Samba in 3 or 4 different modes. It runs make test. It installs it. We don't want our make test to rely on it being installed, so we do the install step last. And if that's successful, it marks it with an auto build by line in your commit in the top commit message on the branch. And then a little bit of magic pulls that into master, and that's done in such a way that basically you can't write into master unless you go via this process. And so this is all we do. We have Git auto build, same idea as this Git review that was described in the previous presentation. We have just an alias in Git config and it just pushes to your auto build. There's an auto build tail script you can run on the server, and if you get a cron job that picks up every minute, it goes and looks for auto builds from a particular user. We just simply have one tree per user, so you have one auto build going at a time. And you get a mail if it fails, otherwise it gets merged into master. We think this is pretty simple. We like that it doesn't require any ongoing daemons running anywhere. It doesn't require any foreign languages like Java. It's just a Python script and some cron jobs, which the same kind of philosophy of the build farm. And this has basically been how Samba has been developed for 2 years now. So we've had a trial period when it was first after we decided that we were going to do something like this back in sort of May or June of 2010. It took us a few months to get the machine built together, and then in September we had finished writing the script. That wasn't a very long process to write the script, and it was available for developers to use if they wanted. Of course, if you got past auto build, then you had a pretty good chance that you hadn't broken the tree. And you didn't have to run you should test some stuff locally, but none of us have got the time for running 90-minute test jobs. So it was just social enforcement up to that point. And then we made a team policy in October 2010, and only one developer broke the social rule, and so every other committer got in there, and then in March some Git hooks were put in and just looked for some magic environment variables in the push. So every commit since January 2011 has been via auto build, and Samba's quality, I believe, has never been better. The kind of subtle bugs that you find with things that where you break it here and where you fix it here and you break it over there, those are the bugs where you go and you run the relevant tests and you just and everything passes. and then it breaks the main test, but you've gone off and you're sure it couldn't have been your code. That just doesn't happen anymore. Yes, we have. Up the back.
Yeah, I was just going to ask how parallelized the test run is.
Okay, so the build system is entirely, there's no interlocking between the test running. So you can have 5 auto builds running at once. However, when they detect that master's changed, they restart.
Okay. What
So
about the individual make test? Is that like...
make test is, no, it's all serial. We had thought about
300 lines of C that may change your mind on that.
the issue with the making parallel is that because we actually start up an environment that then runs a series of tests.
Yeah.
It's possible that there are interactions between a test may not leave the environment perfectly the same as it found it. And so if we start parallelising it, even if we set up and run the environments in parallel, they have interactions between each other. And basically, we have enough trouble with flaky tests with it running in defined order before we start running them in parallel. So that's the problem, is that things just aren't isolated enough to... We really should parallelise some of it, but then it's basically someone needs to sit down and be confident enough that as to which parts can be run in parallel. We run, autobuild runs, that's at a make test level. We build Sambas out 3 or 4 different ways, and 2 of those ways we run make test on, and those 2 run in parallel in the autobuild. But the main job that takes the 90 minutes, we currently run as a serial job, simply out of fear for trying to not be just chasing bugs that are just really flaky based on the ordering. But we know it's a problem, and I'd like to get at least some of the jobs done in parallel.
Rob Collins has been writing some code to make that a bit more automated for running things and then looking at the subunit and automatically doing bisecting of my nominal things.
Okay, yeah, certainly it would need to just work with the way and output a consistent subunit stream.
It looks like you guys are already using Testar for some stuff, right?
We've got some Testar stuff in there. I don't really understand enough about what it does or how it fits into things. I know it's to do with subunit, but that's about as far as my...
Rob will be talking about that this afternoon.
No, well, that's partly one going to hang around and just make sure, try and understand, because it's a bit that Yelma, our Python and test guy, Yelma Vinoy, was trying to introduce us onto, but I never really understood enough about what it did or how it worked. So I'll be very glad to learn.
We're about a third of the way of transitioning to it for OpenStack, and it's one of the things. You should definitely talk to Rob, because it's that thing like where it's great and there's subunit and you don't understand it at all, and then one day you're like, oh okay, I get it. But until that point, you want to kill yourself. So you should definitely.
Okay, so for the tape, I apparently really need to get to the Testar talk.
Yeah.
So autobuild hates me. Well, this was happening. I mean, when you've got flaky tests, and particularly if you tend to push to autobuild often, you'll have your autobuilds come back for reasons that don't make any sense to your commit, and so you go and you run autobuild again. Well, there's one developer, I'm not going to embarrass them by naming them, but one who would complain regularly that it's the autobuild just simply hates him. And so he tends to submit more often, or did. But flaky tests can break things, and we basically eventually mark things into a flapping file to try and narrow down it. It's not fun for anyone. We also have a separate job that runs and goes to a mailing list saying about potentially about flaky autobuilds. So basically, it runs an autobuild manually on master, and it should always pass again. So if that ever fails, it goes to a mailing list and we start chasing it down. I've actually had my tests genuinely hate me, but that's because my username is A Bartlett, that's 8 characters. On my 32-bit laptop, that was with a null terminator that wasn't enough to store a string because someone did a size of pointer. Or 60, I can't remember, it was 64 out of 30. But either way, my name didn't fit into the pointer, and that was a fun one to chase down because everyone else could get in, but I couldn't. But the person who believes that autobuild actually hates him, he had a short username. So getting to autobuild, how do we get that far? And how far have I got for time?
Sorry?
Where am I at for time?
You've got 20 minutes, another 20 minutes.
Excellent.
Yeah.
More questions, please. Autobuild is just the final wrapper. The real work is in make test. And under that, we have multiple test frameworks in multiple languages. They all speak subunit or are converted to subunit, however. There's a mix of integration and unit testing. We have long-lasting test environments due to the startup cost. Our provision takes 20 seconds. We can't do that for every test. It just takes too long to get things going, to spin up, spin down for every little unit test. I'd love to do it for a reproducibility point of view, but we just can't do that. So instead we have this, and the complex test environments also interact with each other. You define an environment as being one server. For example, a Windows 2008 R2 compatible DC, and you might have a second one which is a vampire clone of it, which where we have and another one which is a read-only DC attached to that. And so these are all talking to each other and all part of the tests. This slide I also stole from last year. Yes, we write things in a lot of languages. So it's a horrible combination of shell, Perl, Python, make to start the whole thing off. But it's a mess, but it's a mess that we have got to gradually. And this is what happens when you do this as the end stage 10 years in, rather than deciding I'm going to do my tests, and tests are all going to be written in Python or short Pythons of wrappers of a C program or something, some very standard way of doing things. We've got here by, okay, what tests have we got? Can we bolt them together so they run? Because we're not about to rewrite tests and they've all come from a different heritage. So instead we just try and get everything to talk the same protocols and output the same way. We also have some other things. We have ABI checking. So we check in our build system, we actually check that you haven't introduced any new ABIs or if you've changed any. So we do things where we actually run things like NM over a binary, find out all the symbols, run GDB to find out the symbol prototypes, print that to a file. But all this stuff we've done, basically this has really saved us in terms of breaking ABIs and making sure we correctly bump versions for packages and things so that we don't go backwards. I realise there are some public projects that try and do this for whole packages, but we decided to do this in-house. But I know there are some other external tools that can do this kind of work as well. We think whether you're using our scripts or using some of the other projects, this is incredibly valuable just to avoid going backwards. It won't tell you that you haven't broken something in behaviour that totally breaks an existing application, but it gives us a simple check to start with. It's a build time check. We also check for duplicate symbols. Because of the way we bring in a large number of software libraries and dependency systems, you can get duplicates, and we really don't want that. That can get you some very unexpected results. And we can check for circular dependencies. So we do all sorts of checking. We have unit tests and we have environment tests. Now, the testing environment tests, and we have, and this is sort of a description of how the test framework works. As I say, it's all subunit is the glue language and sort of a Perl framework which starts the test and starts running the tests in it. And we have over 9,000 tests. I think there's now 1,500 test suites. It's a lot. This is big, this is complex, and it's a mess. But it's a mess that's keeping us working. And you'd be surprised what tests can trip up. And this is a bit of a description. The reason I'm tripping over some of these slides is I just pinched them straight from Amate's talk last year, but they just seem to... Our talk, but Amate's half of our talk. This is a little bit about how we actually write up and declare tests. So we actually declare tests in a Python script. And so we can then do things like walking over environments and other bits and pieces. So we basically say what the test suite is, what the command is to run it, and that outputs this stuff at the bottom. That is then read in this bizarre, sort of a half markup language. That's then read by our Perl system, which then goes and says, okay, it'll declare the subunit starting stuff for this. It will run it against this environment, so make sure that environment is run, and then this command will actually be run. The environment variables will then be substituted in appropriately for that environment. That can also be done for a shell script, and so we have basically some shell wrappers. And this is stuff I was talking about earlier, that it's all converted to subunit. And so test it goes and runs that and then spits out the expected, the failure lines so that it all appears as a correct subunit stream. We have ways of testing, of getting into the test environment. One of the things that we felt is really important is that you can actually debug a test fails. We don't want to have to start manually creating an environment that's sort of similar to what the test did to hope you can find the bug. You really want to be at a prompt in the same point where your test was. So that's what we have, is we have make test env. And when I first did this up, I literally said, instead of running the test command, just run xterm. It's become a bit more involved than that now, but that's basically the idea, is it puts an xterm of where it was about to run the command. And by doing that, you can then grab that command that was printed out from the previous system slide showed, and then they're printed out when it fails. You basically copy and paste that, you run it again, and then you've got the output. It's not sanitized in any way, nothing's... and so you've got perhaps more information. Sometimes our system filters some of that out. So it's all there. You can start it under GDB. You can walk through it until you can find out what's gone wrong. You can also start the servers under GDB. So because this is a client-server system, the bug's just as likely to be in the server as it is in your test. And so you can get those under GDB. And you can also do it under screen because a lot of...
Two.
So that's our system, but that's just testing Samba against Samba. The nasty words that could describe some of that. It's not really real testing if what the rest of the world is running is Windows. And just testing against yourself just doesn't really. It's great, but we have some real problems with it because we have those SME torture tests that were written to pass against Windows. Well, they get changed, and did someone really revalidate the change against Windows? Do they validate it against the current version of Windows? Did we change some aspect of the libraries underneath so that they work perfectly fine against Samba, but they're no longer actually proving anything about our behaviour relative to Windows? So Tridge and I went and spent a good deal of time trying to do WinTest. So the idea, well, why don't we do this level of automation against real Windows? Virtual machines have come of age in the time between when our make test system started and staying this. So we use virtual machine snapshots, and we run Samba really as root because we want to actually check. We actually have had Samba release with security holes, and we're not telling you anything new because the security fixes had to go out with the embarrassing note attached, where we had some access control stuff that was missed because our test didn't run as root, and so we never found out that we had the problem. So we wanted to actually run some stuff as root and just check some basic things, bind to real ports. I was talking about faking everything before. Well, this is trying to do the opposite, to actually really run it. And do things like join a real Windows domain, join Samba as a DC into that real Windows domain. Sounds great. Sadly, it became really too hard to set up and unreliable. Setting up involved configuring up a number of Windows machines, getting Telnet installed, getting various bits and bobs installed on a machine. You have to install the Telnet server, you have to put everybody into the Telnet clients group, which may not yet exist, you had to create it. Install a few other little tools that we would interact with. So it would take you most of a morning to get your Windows machines all installed up, turn off automatic updates, turn off the firewall, all things you need to do to be able to interact with this machine. It wasn't taken up by the rest of the team. Thanks. It was, I think there were only 4 users ever worldwide, because that's how many config files you got. The tradition is you submit your config file into the repository. But even with me being the only person regularly running it, it actually saved our bacon with Samba 4.0. We made some late changes for access control stuff, and we actually caught the failure before we released Samba 4.0. There are still other issues that 4.0 went out with, but we actually found that we had broken a significant part of domain join stuff because I was able to run WinTest and to show that, that those changes were breaking it. I would have really liked it if this had been taken up more. I would have really liked it if it was more reliable. There are some really odd bits, particularly if you connect it over Telnet and you're trying to reconfigure this Windows IP configuration. It don't always come back to you. So that's flaky. I perhaps need to talk with some Windows developers about how to try and configure that in a more reliable way. Okay, that's my last slide. So that was our last sort of attempt at it. Was try and do it with automation. Was try and do it with Windows. It wasn't unlike the make test, which has become a core part of our process and everything else. The win test stuff never really got picked up. In many ways, the make test didn't earlier, but there's no way that we could force such an unreliable system into being our gating process. I would just simply have everybody screaming. That said, we're still, I still run the win test occasionally, and I still find it I'm not a manual testing guy. I don't like manually going through so I prefer to spend more and more pain trying to make my win test thing just work this time and kick it along the road a bit longer. But that's sort of where we've done with testing and how we've used it. We like sort of what we've done with autobuild. We like that it's fairly lightweight, and I like that the exact environment that's being run on our test server for gating, I can run on my laptop. And that's a really big thing for us, because you can run a local autobuild and you can then run bits of those tests locally and try and debug them without needing the whole cloud stack that you're running it in. Now, I would like some more questions, because I think I still have a few more minutes. Okay. Yeah?
I didn't quite understand one of the problems. The reason that people didn't run the tests was because they were so slow.
Yeah.
And you were saying with the auto build or the make test, you didn't actually parallelize it. So isn't it still really slow for developers? Yeah, but you do a git auto build, and you get an email later that says it all mucked up, and go back and redo your work. But you're not. Because that's something else off in the background. You've just done git auto build, and that's your last mental thought about that until you wait for the email to come through. Okay, right. Unless you decide to tail a test. But there's something psychological about the difference of running the test here, and then I'm going to run manually git commit, git push, and so then you shortcut that, compared to I've started the process that if successful will push to master. And so it's that thing, because I want to get out to dinner, I want to get on with my day, most of it's passed, I'll just push it, and then it doesn't work. Whereas this is automated, that it will go to master if it's successful.
And you said that if it notices that master's change up from underneath it, it's going to stop it and restart it.
Yeah, so if master changes underneath the tree, there's a job runs every minute in the auto build that checks for a change in master, and it just starts the whole thing again.
Cool. So you're doing the same thing where you're testing what's going to land. Exactly.
We'll test him, and I was worried that with a 90-minute auto build that we would have trouble with maybe a land 20 patches a day or less. It hasn't seemed to have been a problem. I was really looking for a busy development period and wondering when it would get backed up so far that because you can imagine that the load goes up and these competing jobs are racing against each other to finish. And yes, you can be 6 hours to get your patch in if it's a busy day, but I've never actually had it get to the stage where it's clogged up. So it seems, but we only have really a dozen active committers, so at any one time. There's more than 20 people on the team, but it seems there's never more than a dozen or so people going. So that seems to be how that manages to work for us. Yeah. It certainly is going to be that serialisation is going to be an interesting challenge in the future. But we could do same thoughts on the speculative execution came to our mind, if it ever gets to that.
Yeah, and if it ever does get to that, I imagine that the specialist majority our tooling is written in such a similar thing would probably directly lift.
It wouldn't be too hard to fetch around a few different auto builds. Yeah. The other thing is that auto builds, Tridge has got the stats on how many times auto build fails. It fails a lot. The number of bung auto builds put through is horrendous. Because basically we've got to the point where we'll run a few manual local tests and we'll auto build to know that the rest is being handled. So it's a bit embarrassing, but it's become a replacement for actually running my test locally, which it's good and bad. But at least it's consistent. It's on a consistent environment that everyone else is the gold master for where it should pass. So, and the code quality seems bears it up. That I'm very happy with how Sambas got out with this system. Other questions? Yep.
Is there any thought that you might stop faking it at some point, given that VMs are so ubiquitous now? You may as well start using real.
So the question was, whether we should stop with the fake auto build, the fake wrappers, for everything, and start moving to testing on real VMs. Well, that essentially was what we were trying with WinTest, and that was, a fairly. I'm just going to do that. That was most of the Windows side but it's also that developers have all chosen different virtual machine environments. So you'd have to do the same. WinTest has got stuff for how to run, plug in the commands, starting a snapshot here, doing these things. I don't see us actually moving away from what we've got. It's too easy to, within your shell, within your existing GDB, something where your processes are just there and can be GDB'd on the spot. I think we seem to be moving more down that road rather than less, because we'd have to define up the standard Linux distribution that our tests are going to run in, and a lot of other stuff would have to be defined and then imported as virtual machines to every developer. Or we give up on that and only run things in the cloud or something. And I think it would be something to be done in addition. The next thing that we do need to start testing with is we'd really like to put a different operating system into auto build. We're not quite sure how we do that. We haven't, but it keeps on being, wouldn't it be good to have it also test against FreeBSD, just to cover the Linux and BSD as must work before you can push. And that'll probably start bringing up how we do that. A VM was a thought, and so I suspect that's maybe how we start down that road. But currently it only tests against one version of Ubuntu on our test server. But yeah, that's sort of where it is, the direction we've sort of taken. There's lots of little steps, as you can see. Just one little step after another has led us to this goal, rather than a real thought that for that end goal we'll want to do these steps. Because you're right, we probably would choose something much more, staying now, we'd choose something cloudy, spinning up virtual machines and things, I think. Other questions? Yes?
How do you keep your test coverage up? I think you said about 50% would go up and down if you were going
How do I keep the test coverage up? We don't really look at it very much. I'm going to dare to. Oops. I've only got a couple of minutes. On build.sab.org, there is a link to our test coverage page, and we occasionally look at it. We don't obsessively go after it. We should look at it more often. I've got one of the build farm hosts spitting out the test coverage as part of its job twice a day. Probably should lower it to once a day because nobody looks at it.
How do you calculate the test coverage?
Test coverage is simply calculated by that line of code was run during the test. It doesn't calculate whether the code was run, produced correct output or whatever, just whether you went past that line of code. And simply, the rule is simply whether whether the GCov instrumenting of it saw that line of code run past. Because it's all based on GCov, processed through the LCov wrapper for turning into HTML and then uploaded. And so it's not very good. It doesn't tell you much. It simply says that we went past that line of code. But it's all we've got for getting any idea how much we've done. Yeah?
How much time spent writing tests compared with writing code?
How much time spent writing tests? We certainly do have an emphasis on tests, and the thought is generally to try and write the test before you write the code, although it usually doesn't happen that way. You usually find that if you don't write tests, you find yourself bitten later when that code really was just totally broken and you didn't test it. I don't. It's hard to say. I'd like to think it was half-half, but I suspect it's not.
What do you feel is like the biggest thing that's holding you back with WinTest? Is it just
what's the biggest thing holding me back with WinTest? The unreliability of setting up the network stuff. I probably should just hard code it into the virtual machine at the snapshot stage.
on the Windows side?
Yeah, it's the setting some things up over the telnet connection, and some things like we just seem to run into timeouts and run into some things. Basically, the Windows machines just feel flaky. Now, I'm not entirely sure why. But a lot of it's around trying to configure the network to appropriate for the environment. That seems to be the worst bit of it. and there's some other flakiness. It's odd, the actual DC promo domain join code, sometimes it just doesn't seem to quite work right. It's just still running there. And maybe it's just taking much longer than I'm expecting, and a 2-minute timeout's too short. Just in general interactions with Windows machines, most common thing I just notice is the telnet session just end in timeout, and I go, I'll just try it again. It really needs to sit down and maybe find some more reliable ways to communicate with the Windows machine. I don't think doing over telnet seems to, and with the command line tool, seems to work the best. That's where the flakiness seems to be, and it's a real staying the virtual machines up and things is sometimes a bit of a challenge. Sometimes they always seem to come back up, but it's just a bit. It never really quite worked out, and it surprises me. But
so if I just search for Samba Wintest, will I find whatever you do?
Yeah, it's in our main master repository. There's a Wintest page in our wiki. There's a master, and there's the Wintest scripts are in Wintest in master. And I think that's me.
Questions, then talk to Andrew afterwards.
Yeah, I'd be very glad to take questions.